talk about the combined gas law. Sometimes it isn't possible to hold P, V, or T constant. When this happens, we can use the combined gas law to predict how the changes will affect multiple variables. You will notice that the combined gas law is just like it sounds. It's a combination of Boyle's, Charles, and Gay-Lussac. Some important things to keep in mind: that if a problem says something is held constant, that variable will not be needed in the problem. So for example, if it says pressure is held constant, you're just going to deal with volume and temperature, thus resulting in Charles's gas law. Let's take a look at the equation. The combined gas law is P1 V1 over T1, which is equal to P2 V2 over T2. We have Boyle's law, P1 V1 equals P2 V2. We have Charles V over T, and we have Gay-Lussac's P over T, thus resulting in the combined gas law. We're going to do some practice now, so gather all your necessary materials to do some practice. All right, we're going to do some combined practice problems. Just a reminder, our equation is P1 V1 over T1 is P2 V2 over T2. Temperature does need to be in Kelvin, so if you need to convert, Kelvin is equal to degrees Celsius plus 273 degrees, okay? So keep that in the back of your mind. Pressure must be in the same unit and volume must also be in the same unit. All right, here we go. A sample of ammonia gas at 25 degrees Celsius has a volume at 3.5 liters and a pressure of 1.68 atm. The gas is compressed to a volume of 1.35 liters at 20 degrees Celsius. What is the current pressure? So I'm going to make my list of variables. I have P1, V1, T1, P2, V2, and T2. And let's fill it in. So a sample of ammonia gas at 25 degrees Celsius, okay, I know I don't want Celsius, so I have to add 273, has a volume of 3.5 liters, and a pressure of 1.68 atm. The gas is compressed to a new volume of 1.35 liters at 20 degrees Celsius. So I see Celsius, I need to add 273 right off the bat. And then I'm solving for P2, okay? So 273 plus 25 is 298, okay? We know our equation is P1 V1 over T1 equals P2 V2 over T2, so we can plug things in. So 1.68 times 3.5 liters over 298 is equal to X times 1.35 over 293, and then we're going to cross multiply. Get our purple going, get our green going. Oh well. All right, so 1.68, we can rewrite it even, 1.68 times 3.5 times 293 is equal to 298 times X times 1.35. We're going to multiply this side. 1.68 times 3.5 times 293 is equal to 1,722.84. 298 times 1.35 is 402.3x. We're going to divide each side by 402.3 to get x by itself. So then x will equal 4.28 ATMs. And we know it's ATMs because our first pressure was in ATMs, so then our second pressure also has to be in ATMs. Take a second, check your work to see if it matches mine, and we're going to do one more combined problem together. All right, our second combined problem, we know they're variables, so we're going to go ahead and list them. P1, V1, T1, P2, V2, T2. Okay. A gas at 110 kilopascals and 30 degrees Celsius fills a flexible container with an initial volume of 2. If the temperature is raised to 80 degrees Celsius and the pressure is increased to 440, what is the new volume? So my initial pressure is 110. My initial temp is 30 degrees Celsius. We don't want Celsius, so we're going to add 273, and we get 303 Kelvin. With an initial volume of 2 liters, the temperature then goes up to 80 degrees Celsius. We don't want Celsius, we need to add 273. So 80 plus 273 is 353. Our new pressure is 440 kilopascals. So we want to know what our new volume is. So our new volume will be X. We know it's P1, V1 over T1 equals P2, V2 over T2. So P is 110 times 2 over 303 is equal to 440 times X over 353. And then we're going to cross multiply. So 110 times 2 times 353 is equal to 303. Not sure why my marker is doing that. Times 440x. So 110 times 2 times 353 is equal to 77,660 is equal to 303 times 440. And we get a really large number of 133,320x. We're going to divide each side by that to get x by itself. So then x is 0.58. We know volume is in liters, so our second volume is also in liters, so x is equal to 0.58 liters. If you have any questions, make sure you check in with your teacher.